What we're going to cover today is a lesson on wall framing. Basically, we have to go through and understand all the components and how they fit into our building before we even go out and start framing walls. So let's start by understanding a little bit about the wall structure and what all the components do. Now, it's going to be very important that you understand all the names involved in the wall frame. Right here, what I do is have all the names called out on this picture, but you can also reference all these components in your classroom. This is a mock-up that's sitting in the back of the classroom with name tags on it. You need to memorize all these names. What I want to talk to you a little bit about today is their function in the wall structure. So let me walk through this. Here we have what's called the king stud. It actually supports the house. It then goes in between one of the top plates and the bottom plate. Again, moving on over, we have another king stud. Next to the king stud, what you're seeing is called a trimmer or jack stud. What this does is support this item, which is called a header. Now, the purpose of the header and the purpose of the whole wall is obviously to support the house. What the header does is allow us to put openings in walls without compromising the structure of our house. So what a header does is transfer the loads or the weight of the house away from the window. It takes it and laterally distributes the weight onto our trimmer, and some of that weight does go into the king stud, but most all the weight goes right into the trimmers and then transfers all the way down into our foundation. So basically what this does is allow us to cut holes in our walls and create openings. Obviously, it's nice to have windows and doors and things like that in your house. So that is the basic function of the components that you're looking at right here. And again, reference those mock-ups that I have around your classroom that are going to be really helpful in understanding all the components. So let's start out by talking about walls and where they're going to fit into our building. So there's going to be 2x6 walls and there's going to be 2x4 walls. Now, 2x6 walls, as you now know, are going to measure 5.5 by 1.5 in terms of size of lumber. And the 2x4 walls are going to measure 1.5 by 3.5 as far as lumber goes. And again, this is considered dimensional lumber. It's actual lumber that's cut from trees and directly from trees. No real additives at this point to them. So that's why we refer to them as dimensional lumber. Now, in terms of wall heights and buildings, it really varies. Our wall height is going to be 8 feet, but I'm sure you've seen, you go into different buildings, different structures, wall heights can vary anywhere from 8 feet to 9 feet to 10 feet to we do things called balloon framing that gets us walls as tall as 20 feet tall. So it just depends on the structure. And once again, always refer to your plans in terms of height of walls and location of walls. Now let's get into the specifics of what we have in our walls and how we select that material to go into the walls. From your mock-up in your classroom, you guys know that there's going to be a bottom plate and then there's going to be two top plates. These are super critical in a sense. They determine how straight our wall is. Let's picture this. If you took a top plate and a bottom plate and you put all your wall studs in between them and the top plate and the bottom plate were wavy, your entire wall would be wavy. So what we do when we select our top plate and our bottom plate to lay out our walls, we select the best lumber we can get. And we're really looking for straight lumber. Believe it or not, obviously, lumber's naturally occurring. It's going to have all kinds of defects in it. It twists, it bows, it cups, it waxes, it wanes. It does all kinds of things. In other words, it's not perfect. All right. So what we have to do is try to pick the most perfect ones for our top plate and bottom plate. So we walk out of here with nice straight walls. Also, as you're selecting these, you're going to find what I have here is a 10-foot wall. You're going to have 12-foot walls and maybe even 15-foot walls. So what I want you to do is select the appropriate length lumber for the appropriate wall. If you have a 10-foot wall, do not grab a 16-foot piece of lumber and cut it down. Look for a 12-footer or a 10-foot piece of lumber. Most likely we will have 10-foot lengths of lumber on site for you, or 12-foot or 16-foot lengths. Do not take a long piece of lumber and cut it down for a shorter wall. So we're trying to be efficient and utilize lumber as best we can. Now, when we're talking about walls, we also want really straight walls without bows vertically. So what I'm talking about now is wood imperfections, and it is referred to as crown. Remember I told you there's all kinds of defects in lumber. What crown is a basic bow in our stud. You can imagine this can wreak havoc in the straightness of our walls. So when we start framing our walls, and our walls are all going to be framed on the ground, not on the ground, excuse me, on the platform, on the deck of the house you're going to be building, or on workstations. You're going to be framing these up, putting them together on flat level surfaces. What we want to do is keep the bow of the wood, known as the crown, all facing the same direction. Ideally, it's going to be up. And then when we stand the walls, it's going to be facing out. It's important, though, we just maintain the same direction. You can't put one wall with the crown facing in, the other wall with the crown facing out. You're going to wind up with a real noodle and a bow in the wall. So we're going to try to keep our crown, our bow, and our lumber all facing the same direction. And you can determine the crown of the wood literally by picking it up and looking straight down it. You'll pick it up right away. And again, throughout class, we're going to go through how you look for crown, but it's a pretty basic task in terms of just looking straight down, and it becomes very obvious when we start doing that. So now that you know the names of the components from looking around the classroom and in all your mock-ups, this is an idea of how we're going to start laying out our walls. When I say layout, layout refers to our spacing of our wall studs. So you're going to hear this term all the time: on center, 16 inches on center, 19.2 inches on center, 24 inches on center. These are all standard increments for placing your studs, the distance in between them. And we measure from the center of the stud. I mean, obviously, it's also from the front to the front, but we're always referring to 16 inches on center. There is a very, very important reason for that. We're going to find out in our next module that a lot of our components, sheet goods they're called, that go on top of this, the things you walk on and the things that keep our wall supported, are built in increments of 4 feet and 8 feet. So it's really important all these things match up, which we're going to talk a whole lot about coming up. But this is just a basic rundown of what you're looking at when we start framing up our walls. Up next is going to be part 2 of your wall framing, and we will progress on through till we have enough knowledge that we can actually get out and start framing our walls on an actual building. So that concludes our lesson on wall framing basics. Bye-bye.